So before we check this, let's kind of do a quick review of what we learned about probability last week. Remember we spent the first day or day and a half, I guess, on fraction review, just because it's important, but also we use that in probability a lot. Then we started talking about just the basics, what is probability and that kind of stuff. So let me go to the page. There we go. Remember, probability is chance or likelihood of something happening. And we typically will show that as a fraction because most of our work will end up with that, but also we might use decimals or percents. Remember, it has a value of 0 to 100%, or in terms of decimal value, 0 to 1, just a whole number of 1. This box, this red box formula is going to be kind of the backbone of a lot of what we do, which is saying probability of something happening is the number of ways it can happen out of the total ways that we are dealing with. So we worked through those first couple pages of the packet, and you guys did really well on that, kind of cruised right through it and got used to writing P of some description in parentheses, and then start with the total, like rolling dice was a total of, most often if we were doing sums or products, it was how many? You guys remember your chart on your packet? What was our total in those cases? Like total sums, total products of 2 dice. It was 36, yeah, because we had 6 from the first die and 6 from the second, so 6 times 6 made 36 possible outcomes. We talked about sample space. The big description that we used was over here, not how many, but what are the outcomes that are possible. So in terms of your packet, let me go to that. Actually, I don't want to take time. You have the packet. So your outcomes for sums were the sums 2 through 12. The outcomes for products were 1 up to 36, various numbers in there. So it was what were the outcomes, not how many. All right, big deal. We started on Friday kind of later, was this last piece. And I put that it's question number 1 because you'll have a series of questions that will help guide you to the right probability calculation. Kind of like, do you guys remember solving quadratics? Our first question was always, is there a bx term? And if there was, we did one thing, and if there wasn't, we square rooted, and that directed our work. So that's this. So is it or is it and probability situation? And it's not huge, it's most of the time not going to be subtle. Like it's not going to be, you don't have to read between the lines. Usually it will say the word or it will say the word and. Okay? We did talk about or increasing probability because it allows for more successes, but and probability decreases the probability because it means more things have to happen. Okay. And let's just do a simple one. What's the probability that one or another of you, let's say, do something positive. Gets a gift certificate for Starbucks. What's the probability that somebody in here? That's another way of saying it, right? Well, do you see how that's kind of like his probability plus hers, and yours, etc. Versus if I said, what's the probability that all of you, in other words, hers, her, and you, that's going to be lower, right? Because now everybody has to get that gift certificate. Okay. So this warm-up is hinting at what to do with this, okay? And each of those 2 sections, or and are going to have questions in them. So Allie spins and draws. So it sounds kind of like an and problem, doesn't it? A little bit. She gets a 3 and a 3 on both. And then she sets the card aside, spins again, draws another card. So is it possible for her to get a 3 on her second spin? So here's what we would be looking at if I asked you a probability. It would say on the spinner 3 and 3. Okay? That's how it would be in our parentheses for the probability statement. But first of all, is it possible for her to even do that? Could she spin a 3 and then spin again and get another 3? Yeah, everybody's saying yes. Okay. How about the card? Is that something that even makes sense to ask? Can she get a 3 and another 3? No, because of this phrase right here. Sets the card aside. Meaning, once I draw that 3, that card is gone, and I don't have that as an option anymore, right? So based on the conditions of whatever this game is, she can't do that. All right. How does getting the 3 card on her first draw affect the probability of getting the 2 card on her second draw? So this is, again, we're doing card probability over on this side. So 3 and 2 is kind of what we're asking. Probability of 3 and a 2 on the second draw. How does the probability change? Okay? So let's ask the first question. I'm going to take this off for now. What is the probability of her drawing a 3 on the first draw? Don't complicate it. It's 25%. Where'd she get that fraction-wise? 1 out of 4. Yeah. So drawing a 3 is 1 out of 4 on the first draw. Okay. What happens now, though, is she sets that aside, and what's the probability of drawing a 2 on the second draw?
One out of 3.
It's 1 out of 3. Now, why?
She only has 3 cards to choose from.
Yeah. So do you see how the probability changed? Okay, that is an example of one event influencing the probability of another event. So we have to study how to solve those kinds. And so the question there is independent versus not independent. Okay? So does one event affect another? Think about probabilities that you guys deal with. How about the weather and your clothing choice for the day? Like, are those independent, or do you think one affects the other?
Yep.
I mean, it does for me. Like, if it's really cold, I wear something different than if it's 90 degrees, right? So if we turn those into probabilities, like what's the probability that you wear shorts if you know that it's 25 versus 70? See, it would change it, right? Okay. So this is one case where we're dealing with 2 different events. It didn't ask this, but what if I said the word or? So on the spinner, what's the probability that I spin a 1 or a 4 on the first spin? Well, what's the probability of spinning a 1? 1 of 4. What's the probability of spinning a 4? Also 1 of 4. What do you think we do with those 1/4? Those 2 1/4? Okay, so she's saying add. Okay. So this is where we're going. We're going to start with the or case, and then we'll deal with the and case. It's a little bit more complicated. And I think you'll pick this up pretty quickly. So, or probability. That was our first question. And let's see, let me skip a couple of things. Our next question is going to be, see, I've highlighted this, is if we know that it's or, we need to know, are these 2 events mutually exclusive? Do you remember us talking about this on Friday? and what it meant. Mutual means like between each other, and exclusive. What happens when you're exclusive, like dating? What does that mean? Dating exclusively means. You have your hand up?
I wasn't gonna answer what word means.
Not there yet. I'm asking what does mutually exclusive mean? Because have you ever heard that phrase? Like I'm dating exclusively. Oh.
No.
Okay. Well, it means that I'm only dating one person, like, right? It excludes other people, which is that's the way you should date. Some people disagree. Okay, let's just write it then, and then we'll have that to reference. So I want you to kind of, this is going to be a little bit of a flow chart. So I want you to separate the or and the and side. If it's or, then question 2. I'm going to write a different color. Is it mutually exclusive? Hello.
How are you?
I'm good. How are you?
Asking to see if this person's here.
No. I'm not sure why, but
Have a good day.
you too. We're gonna write about this on the next. At least I am. If you guys have room, you're good. But I'm gonna write about this on the next page. If it's and probability, then your next question is it independent? And we'll talk about, we might get to that today, but we'll see. All right, let's talk about what mutually exclusive means. So, kind of keep this organized under the heading for or probability. Emma, what's up over there? Come on, you can do it. Alright, mutually exclusive means this. It's actually a pretty simple meaning. It's just a wordy thing to describe it, which is kind of annoying. So it cannot be two different things at once. That's all. You can't be in math class and in ELA at the same time. Yeah. Can you on a die, can you roll a 2 and a 5 at the same time? So are those mutually exclusive? rolling a 2 and rolling a 5, are those mutually exclusive? Yes. Mutually exclusive means they cannot be the two things at once. Okay? So maybe some examples. So you can't flip heads and tails at once, right? It's not going to be both. It'll be one or the other. Can't roll 2 and 5 at once. You guys think of one. Karen, how about you? Think something kind of probability-wise. You can. Does anybody have one? I kind of put him on the spot. That's awesome. Can't drive a car and walk at the same time. Perfect. Yes, that's true. Well, it's pretty hard to eat and drink at the same time. Okay? And then, like, probability-wise, if I said, what's the probability, and I asked you this one last week, but what's the probability, I don't know if you're a Broncos fan, but they play this week, of the Broncos winning or losing? Like, can they do both at the same time? No, it's got to be one or the other. They either win or they don't win, but it can't be both at the same time. So, there's unfortunately all the betting and all the people who do statistics of who's going to win. Like, they can't treat those as non-mutually exclusive. They have to be mutually exclusive. Okay. So when we have probability that's mutually exclusive, it is exactly what Bailey said. So ME, are we good with that abbreviation for mutually exclusive? Okay. So probability of A or B, and it could go on. It could be C, D, E, F, G. We'll just leave it at this for now. We just add them up. It's exactly what your gut would tell you to do. Okay? So I'm going to box this. This will be an important formula throughout the unit. Okay, so think about this. What if I asked a silly question and said, what's the probability of rolling a 6 on a die? Actually, let's simplify the numbers. What's the probability of flipping tails on a coin? It's 1 out of 2. Okay, ready? Don't write this because I think we'll do a more complicated example. Probability of tails is 1 out of 2. Probability of tails, not plus, sorry, or heads is what? It's 100%, right? It's either going to be heads or tails. So I would do 1 out of 2 plus 1 out of 2, which is 2 out of 2 or 100%. One of those is going to come up. Like it, I suppose you could argue it could land on the edge and balance there, but it won't, right? That's not really a thing. Okay. So same with the dice. What if I said probability of rolling a 1 or a 2 or a 3? Yeah, they're each 1 out of 6, so it would be 1 plus 1 plus 1, or 3 out of 6. Make sense? If they're mutually exclusive, we can just straight add them because their probabilities don't affect each other. Okay? Let's put like a little, I guess go ahead and write the tails and heads thing. Please underline the word or so you see that. And we're calling this an example. So this is probability of tails plus probability of heads, which is 1 out of 2 plus 1 out of 2, which is 2 out of 2, or just 100%. Make sense? Okay. So far, what are our questions? Like I hand you a probability problem, what should you ask as you get going on it? I'm going to ask you this a bunch over the next week. What's your first question?
Is it mutually exclusive?
Before that? Here you go, here's a probability problem. What's your first question?
Is it or?
Good. Guys, you should be, hold on. Maybe we should highlight this a little bit bigger. So take your, if you have a highlighter, like draw. Draw something that draws your attention to this section. And keep going back to this, and it'll help because I'll keep asking you. So question 1, is it or and? Right? Question 2, is it mutually exclusive? That's if it's an or case. Or is it independent if it's an and case? Now, we'll probably come back later and add, is this combinatorics? Is this binomial probability? We'll add those things on here, but for now, this is where we are. Everybody good? All right, let's go try one. Okay, read this one. It was up here a second ago. We're rolling a standard number cube once. So, guys, a number cube is a die. It's a dice, right? Roll it. Don't worry about the E's and all that for now. E and T. What is the probability that you roll an even number or roll a 3 or 5? Is this or? So question 1 is what? Is it or and? Which one is this? This is or. So probability of even or 3 or 5. That's what we're trying to figure out. Okay, next question is what? Yeah, we have decided it's or. Okay, so that's question 1. Question 2 is it mutually exclusive? What does mutually exclusive mean? What does mutually exclusive mean?
Cannot be two different results.
Yes. So in this case, we're saying, can it be even or a 3 or 5 at the same time? If you're working with me, maybe you should write this. Can it be even and 3 or 5 at the same time? That's what we're asking when we say mutually exclusive. What do you think? Can it be on the die, 1, 2, 3, 4, 5, 6, can it be an even number and 3 or 5? No, because what are the even numbers?
2, 4, 6.
2, 4, and 6. So it can't be those and a 3 or 5 at the same time. So is it mutually exclusive? It is mutually exclusive. All right, so what's our formula? So it's going to be P even or 3 or 5 equals P even plus P 3 or 5, right? What's the probability of being an even number on this die? 3 out of 6, good. What's the probability of 3 or 5? 2 out of 6. Okay, so what's our probability overall? Yeah, remember we just add fractions, we add numerators. So we basically only excluded 1, right? Otherwise everything else was a success. That's a good example, like a good process of mutually exclusive probability. First question, is it or and? Second, if it's or, is it mutually exclusive? If it's yes, just add your probabilities up. Make sense?
Can we write down what's exclusive? Yeah, on the procedure.
For mutually exclusive?
No, for just the exclusive.
Independent? We don't
Yeah.
have it. Is that what you're asking?
Yeah, and,
No, we haven't done anything for it.
okay.
Other than the question, is it independent? We haven't written anything else down. Do you want an example like this in your notes or not? Or is it basic enough that you don't need it? I'm happy to do it. I just need some of your opinion. What do you think?
Yeah.
I hear ya. Okay, let's just put one in there. Might as well. We're not going to use all these boxes, so. All right. So I would start by writing the first question just because I want these to be locked into your head so that it's kind of automatic. Okay, so we're going to assume that we have said yes, well, we've said or and we've said yes. Okay? So it's or and it's yes. I'll write a problem in a second that has that, but here's that problem. Man, this is squeaky. So we're talking about standard card deck. You have that breakdown on the front of your packet. So draw a 4 or flip a tails. So you kind of have to know the context. Like we're not flipping a card, we're flipping a coin and drawing a card. Is this or and? Or, it says the word or right in there. Is it mutually exclusive?
Yes.
Why?
There are two different things.
Can I be a tails and a 4? No, that doesn't even make sense, right? One's a coin and one's a card. So maybe just to make sure that you're clear on that, write that out. Yes, because it can't be tails and a 4 at once. Everybody kind of getting more clear on mutually exclusive? Okay. All right, and then step 3, write your equation. This is 2. This part is pretty typical. Like once we've identified the situation, we want to write our equation. So probability of 4 or tails is probability of 4 plus probability of tails. So we're just using that boxed equation that we just wrote on your notes. And then what is the probability of drawing a 4? So I guess step 5 is just solve, right? Find the individual probabilities and add them. So what's the probability of a 4 in a regular deck? You have that chart if you don't have it memorized. How many 4s are there in a regular deck? If you're playing cards, how many 4s are there? There are 4 of them, right? 4 4s out of how many cards?
52.
Okay, so probability of 4 is 4 out of 52. What's the probability of flipping a tails? 1 out of 2, yeah. Uh-oh, we have different denominators. How do we deal with that? We have to add our fractions. How do we do that? That's on your front page.
Multiplying both top and bottom by the same number.
Yeah. Let's finish this real quick. And then we'll take our break. Okay, this one is going to stay the same because it's 52. If I multiply, what do I need to multiply 2 by to make 52? 26. Good. Okay, so 4 plus 26 out of 52, so 30 out of 52 is our probability of doing both things. Okay, of course, could you turn this into decimals and make it a percentage? Yeah, you could have done 4 out of 52 plus 0.5, right? 1/2 is 0.5, and added those together and made it a percent. That would be okay. It's fine. All right, take your break. Any questions on this example? Okay. All right, well, see what you can come up with on this one. This one, read carefully. We're just going to pause here and do this kind just to point out something, and then we'll come back to this in a minute. So what is the probability that you roll an even number and a 3 or 5 on a regular dice? An even number and a 3 or 5. You roll it once. Don't overthink this one. What does it mean to roll an even and a 3 or 5? Those are the options when I roll this die. There it goes. I'm asked, what's the probability of rolling an even and on that same roll a 3 or 5? Good, Emma. Good job. Anybody else? What are you feeling? Tell us about that.
It's not possible. You can't roll them at the same time.
Can I roll one of these two and at the same time have it be an even number? No. That doesn't make sense, right? That's like saying, what's the probability of winning and losing at the same time? Just by score, like all that. So what's the probability of this? What's our answer?
None.
Yeah, but what do we use for none?
0.
0, right? It's just 0. You could say 0% or just there's no chance, right? It's not going to happen. It's impossible. So you guys, you got to read these carefully. Like I said, don't overthink it. I'm going to skip that one for now. You guys try both of these questions. Okay, so we have a box with 100, some kind of ball in there. 30 are purple, 10 are orange. How come that doesn't add up to 100? Yeah, there's other colors in there. So does it have to? No. So, probability of P, I'm just going to abbreviate. All right, what is your first question? And or, which one is this? This is or. Okay, now we ask, is it what? Mutually exclusive. So what does that mean in this case? Can the ball be purple or orange when? At the same time. Guys, we got to get this mutually exclusive thing, okay? It's not a big deal. Can it be this what you're asking at the same time? That's what we're saying. Can a ball be purple and orange? No. Okay, so again, question 1, and or. It's or. Question 2, mutually exclusive or not mutually exclusive. So I'm abbreviating. It's mutually exclusive because it can't be orange and purple. Can't be orange and purple. Can't be the same thing. It can't be both things at once. So, what's our formula for this? Guys, do you have your notes out? You don't have to have it memorized, but I expect that you look it up. If it's mutually exclusive, we just add the probabilities, right? So probability of purple plus probability of orange. Well, what's the probability? I wish I had written this better. What's the probability of purple?
30.
Okay, 30 out of 100. And orange? 10 out of 100. What do we do when we add fractions with like denominators? Add the numerators, so we get 40 out of 100, which we could reduce to 4/10, but this is nice because what percent is 40 out of 100? It's just 40%. Okay, so it was or probability and it was mutually exclusive. Okay? Same kind of question, it's just putting a not in the front of it. Okay? So, probability the ball is not purple. Well, this gets a little bit complicated because not purple means that it could be orange, but any other color as well. Do you agree? And same with not orange means it could be purple and any other color. Right? And whatever those other colors are, we don't know, but there's going to be some overlap there, right? What happens when you overlap? If I just straight add these up, is that okay? Here's an easier example. Let's table that one and let me ask it this way. Back to dice. What's the probability of rolling an even or a 2? See if you see any issues with that.
Because 2 is an even number.
Yeah, 2 is an even number, right? So I'm going to write out the list, the usual list, and let's kind of watch what happens. Even covers those, right? 2 gets hit again. But it's the same number on the die, right? So if I roll this die one time, should I be counting this 2 twice? That doesn't make sense, right? So do you see if I just straight add these, I would do 1, 2, 3 out of 6 plus 1 out of 6, and that would say I have a 4 out of 6 chance of getting this. But I don't. I only have a 3 out of 6 chance, right? So we'll call that overlap, where this 2 is part of both descriptions. It's overlapping. And we have to be careful with that. And so in this case, the question, is it mutually exclusive, is no, right? Because it can be a 2 and an even number at the same time. In fact, it is, right? So it's not mutually exclusive. That's the same scenario with these purple and orange balls. These are not mutually exclusive. Not purple and not orange could be talking about the same balls. Like any blue balls or green or black or whatever other color are getting counted here and here. Does that make sense? So we have to be careful. So let's write about non-mutually exclusive. And then I'll give you the formula for that. In your notes, make sure to separate these somehow. I'm just going to put a little green line between them. And I'm going to make this really big. Okay. If mutually exclusive means it can't be the same thing, then what must this mean? Yeah, that it can be the same thing at the same time, okay? Okay. So could a student at our school be a football player and a baseball player? Or a volleyball player and a track star? Yeah. So those would be non-mutually exclusive, right? If we counted some probability in our school, we would have to not double count them in both categories. So, as a quick example, like volleyball and track, or can be a red card and a 6. Those are not mutually exclusive if we talk card deck, right? A 6, there is 2 6 that are red. A 6 of hearts and 6 of diamonds. So our formula has to change to adapt. Here's that. Non-mutually exclusive. So far it looks the same. I'm not going to put the ellipsis, the 3 dots, because I'm not going to give you like 3 or 4 of these. It would get pretty ugly. So we'll just keep it to 2 events at once. Starts off the same. What do you suppose we need to do with that overlap so something doesn't get counted twice? Just throw out what you're thinking, even if it's wrong. If I told you to count something and you accidentally counted something twice, would you just start over and recount, or would you just subtract? Good job. That says subtract P, A, and B. So you subtract the ones that are both things so that they don't get double counted. Okay, I would like to describe this underneath by saying subtract the overlap. Don't double count. And then definitely box this one as well. Alright, so this is, in terms of OR probability, these are the 2 formulas that we're going to use. So we're not going to add any more. So let's quickly go through again. Here's your a probability problem. What do you do first? I just hand you a problem and you know it's probability. What do you do?
Is it and or?
Is it and or or? It's or. Now what do you ask?
Is it mutually exclusive?
Or not. Good. Is it mutually exclusive or not? Okay, we've just determined that it can be both things at once, so now we're going to use this formula instead. Okay? Okay. Have you ever seen one of these?
Yeah.
D&D die,
Yeah.
I think.
Yeah.
All right. So this is a ridiculous name, 10-sided number polyhedron. We're not going to say that.
Just build it to 20 something.
Yeah. I think I used to have one that was like that, maybe. I wish I knew where they went. Whoa, that's cool. It would probably be almost like a sphere. It would be a long time before it settled on a number or something.
Yeah.
All right, so you observe the number that ends up on top when you roll. And then it says let A be the number is greater than 4, and B the number is odd. Okay? So first of all, what's your question? Well, I need to tell you. So is it and or? Good. I have this thing right here. So we're going to just work through it separately. It's or. Okay? What's your next question?
Is it mutually exclusive or not?
Yep. Which one is it? Again, let's read the events. Number greater than 4 and number is odd. So it can't be both at the same time. Are you sure? Well, this didn't say anything about even. There's our sample space.
Oh.
Event is greater than 4, and the number is odd. Are those mutually exclusive? Can you be both at the same time? What numbers qualify as both at the same time? Yeah, 5, 7, 9, sorry. Yes. Okay? So, because you can be both at the same time, what do we have to do? Okay? Alright, so that's going to say A plus B. What goes here? Minus A and B. Okay? Both. Alright, let's walk through this. What's the probability of A? A, remember, is greater than 4. If I just roll a die, what's the probability that the number will be greater than 4? On this one. What was it? Well, it's 6 what? It can't just be 6.
6 over 10.
Yeah. 6 out of 10 numbers are greater than 4. Good? Okay. What's the probability? So B, the number is odd. What's the probability of that?
5 out of 10.
That's 5 out of 10. Okay, do you see a problem if we just stopped here? What is 6 plus 5? And so our probability would be greater than 100%, which we already said is not okay. That doesn't make sense, right? That's another way you can check, is if your probability gets over 1, something's wrong. Okay, here's this new piece. Probability of A and B. So both greater than 4 and odd. So Kyron already said those. Which numbers are they? What numbers are greater than 4 and odd? What numbers are they? It's just these ones, right? Those are greater than 4 and odd. So what's the probability that it will be one of those? No, it's 3 out of 10.
Oh. Yeah.
Right? It's just those 3 numbers out of the whole die. Okay? Now we just do our math. So 6 plus 5 minus 3 is what? Okay, so we have an 8 out of 10 chance of doing one or the other of those events. Either greater than 4, so that section, or a number that's odd, 1, 3, 5, 7, 9. Combining those two, we end up with 8 out of 10 chance. How you doing? It seems I'm looking at some faces that say, I don't get this. Am I misreading here? Are you doing okay? Shall we do an example in your notes? We're about to do an example, but if you want, yeah. What are you going to do with these examples tonight?
Look at them. Discipline.
Alright, here's our problem. Probability of drawing, so actually let me just write it in words. Are you guys good with prob for probability? Okay. Probability, actually let's just call it face card. Let's get some practice with face cards. So probability of drawing a red card or a face card. Out of a standard deck, that's implied. I don't want to write that every time. What do we start with? Here's a probability problem. Okay? Which one?
Or.
Yeah, this is or. Question 2. Now that we know it's or, what's our question?
Is it mutually exclusive or not mutually exclusive?
Well, so you're asking, I'm going to ask Silvana. What question are we asking to know if it's mutually exclusive? Which two things? I'm saying specifically in this problem, what two things are we wondering if it can be both at the same time? Good. So can it be a red and a face card at the same time in a standard deck? Some people are saying yes, some are saying no.
There are red face cards.
What?
There are red face cards.
Of course. Here, on your paper, we're looking at this. Here's red, and here's face, right? So Jack, Queen, King of hearts, Jack, Queen, King of diamonds. So are there red face cards?
Yes.
So is it mutually exclusive? No.
The only reason I know this card is what's that game? Solitaire.
It can be red and face at once. All right, which means we need to write our formula. Write the non-ME formula, which is what? P, I'm going to shrink that a little bit. You guys look at on your notes if you have it handy. P, A or B equals A, or PA plus PB minus PA and B. So what is our formula actually saying? We're adding the two probabilities and doing what? What's that last piece taking off? Braden, how about you? In this example specifically, what is that last piece taking off? In this case specifically, what is that? Red face cards, right? How many are those? How many are there of those?
18.
Of red face cards?
6.
6. Okay? Alright, so I think in this case, let's kind of make sure we're clear. So probability of A is red. Probability of B, in fact, let's just write it out this way. Probability of red plus probability of face minus probability of red face. That's what this means. because we can't double count the red face cards. All right, I want you to actually do this. Everybody grab this sheet out in front of you. Okay? Get your finger or your pencil. Let's count the red cards. Okay? This is 1, 2, etc., right? Up to 13. Okay, I want you to feel your fingers touch these Jack, King, Queens twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Touch, touch, touch. 13. Everybody with me on the red? Do it again over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Touch, 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 and 13. So we've just counted 26 red cards. Okay, now, so that's, don't flip back, that's this. There are 26 out of 52. Don't flip back, we'll write it in a second. Let's go count the face cards. 1, I just counted that guy twice. 2, counted him twice. 3, 4, 5, 6, I just counted those queens twice. 7, 8, king, I counted those twice. 9, 10, 11, 12. You see how we just counted 12 face cards? Okay? So there are 12 out of 52 face cards. But those 6 cards got double counted. We touched them, counting them twice, which is throwing off the probability, right? So what do we have to do with those guys to fix that problem?
Subtract them.
We have to subtract them because then they go back to being counted once. Right? It's like, it would be like subtracting off one set of dots, essentially. Okay? So we're going to go back and count, or subtract 6 out of 52 that I double counted. Those extra 6 dots that I put on there. All of our denominators are the same, so we can just add and subtract like normal. So 26 plus 12 is 38, minus 6 is 32 out of 52. So do we have a good chance, not so good chance of drawing a face or a red card? 32 out of 52. Is that likely or unlikely? Well, it falls on the upper end, right? It's out of 52, it's above 50%. So that would say it's likely. All right. That's a warm-up, so I shouldn't. Okay. I'm going to hand you a sheet, but before I do that, I want you to see something that we're going to talk about tomorrow. So read this with me, or actually I'll just give you a quick rundown. Do you see a target out here?
Yeah.
Okay. So in it, you can kind of see like a sticky tennis ball. So we're throwing this against the target, okay? So one of the versions, in a geometry class, one of the versions of probability is related to shapes. Okay, so if you stood back there and threw a ball against this target, the goal is to hit it somewhere in this colorful region. So in order to find the probability, we need to find areas of these shapes to know how big the section that I could try to hit is. Okay, so that's how we bring geometry into this, is using areas of shapes that we've studied. And then, do you see on this particular case how there's overlap right there? So if I said, what's the probability of yellow or blue Well, that part is getting counted as yellow and counted as blue. You see that?
Mhm.
So is this mutually exclusive or not? It would not be, because I have overlap. It can be both at the same time, right? That little red, where I put the red rectangle, would be both. So it's the same formula. Add the two and subtract the overlap. It's just that the pieces now have areas that we have to solve for. Okay, so we'll talk about that tomorrow. There's different versions of it. In fact, think of it like a Venn diagram, right? Like if I said probability of red or blue, well, this is both of them, so you can't double count it. But how do you find the area of it? That's what we're going to add tomorrow.